Okay, so I start recording to this webinar number 1 on the round robin test. I think I should see something that it is recording. Sorry. You should all get some pop-up where you have to agree that this webinar is recorded. Can someone?
Yes, this came.
This came.
Yeah.
Okay, so then the recording is happening. Thank you very much. This is the first one we do, so I'm a little bit kind of an untrained person on this. So we will learn about that. I kindly ask you to switch off your microphone and switch off your video, because we want to save some bandwidth in this webinar. And yeah, and with that, what I said already, this is a webinar to train and to learn about the new edition of the 6456 standard for testing washing machines. And it is especially for training people which take part in the round robin test. In this first webinar, we will talk about some general overview on the standard, which will be given to you later by Phil Robinson. I first like to introduce you to this round robin test and tell you a little bit about this. First of all, I have to introduce myself. I'm Rainer Stamminger. And here you see my face. I can also, I think, turn off my video. Now you see me here on a little bit older picture where I have less gray hair. I am chair of 59D, which is a subcommittee which is preparing the laundry standards. And especially I'm convener of the working group 18, which is working on uncertainty, which is the topic of the round robin test. In my normal life, I am a professor, senior professor now at University of Bonn in Germany. And I'm active on laundry appliances testing since many years. I didn't count, but it's more than 30 years where I do work on laundry testing. And I've made many publications. So if you search for me in the internet, you will find many publications. If you want to have a copy of, please send me an email and I can send it to you. Phil Robinson, I think he will present himself later when he takes over in the second part of this presentation here. So I forgot one thing to mention. If you want to say something, please raise your hand and I will try to observe it. And I will give you the floor, so then you can ask any questions. And in between, we will also have breaks where you can ask questions. I am also looking on the chats to see if something is coming up there. So yes, let's go into details. And here, the first question is, why do we do a round robin test at all? Round robin test is a special term which is well designed and well practiced, and it is always done to make interlaboratory comparisons. And we do this now for this new standard of the 6456 standard. And we have many reasons for doing it. The first is that this is a new text, a new standard, and it was written and reformatted and redesigned in many points. And so we want to learn how this new procedure is understood and is applied by the practitioners, so people which are using those standards to test washing machines. The standard is not yet finally published. It is available only in a committee draft, but it will be published, I think, somewhere in 2024 or late 23 if we are really quick. But now we still have the chance to modify it. So we really want to learn where are problems of application. So we would like to ask all the participants in the round robin test also to take notes on problems where you had problems to understand the standard or where things are not clearly enough defined. Please report those problems also back to us so that we can learn and we can improve the standard. We also want to see what are possible differences which come up from different laboratories. So that's why we make this interlaboratory comparisons. So we want to see if laboratories are differently interpreting the standard, which we hope to see when we look on the data which are coming out from these measurements. So this is why an interlaboratory exercise is needed or is helpful to find out if there are different interpretations. And we want to see for sure that if the standard is suitable to make interlaboratory comparisons, so that it can be applied in different laboratories and it can come out with comparable results, even if the tests are done in different laboratories. Because this is one of the main goals of an international standard, that it is suitable to make interlaboratory comparisons of the same product. We also want to take these data to come up with some numerical values about this comparability. This is, we want to use the data to calculate repeatability, reproducibility, and finally expanded uncertainties, which are the measures for this kind of interlaboratory comparison of a measurement methodology. We also want to see if there are specific points in this standard which are, let's say, more or less problematic, which need special skills, where we need to look if there is additional need to make clarifications or to make trainings or to make videos for specific tests. And this we can also include and come out as a result from this interlaboratory comparison. But we also want you as a laboratory to identify problems in your laboratory, and we want you to start to take actions to improve those problems, because we have a lot of new procedures in this new standard, and you may find out that you need to improve your measurement procedures. You may need to improve your stuff so that you give some training to your people. You know now what is needed for the new standard to come, and so you can now prepare for being equipped and being trained to perform tests according to this new standard. So this round-robin test shall also help you to get fit for applying this new standard. And yeah, this is also a part of an education, what we try to do, so that you also have the chance to compare your laboratory against the data of another laboratory having tested the same appliances. And so you can see where you have differences, where perhaps your results are with a higher standard deviation as other laboratories measure the same appliance. And so you can take this as some indication that you have to work on the performance of your laboratory to improve it, to make it even more fit for making laboratory tests using the standard. So there is also a lot of learning possible on your side, not only on our side, which are performing and producing the standard. So there are many good reasons why one should do a round-robin test. And we are happy that a lot of laboratories did agree to take part in this round-robin test. But actually, it's not just one round-robin test which we are doing. We have actually 8 round-robin tests which we are planning. And I want to introduce you shortly to these round-robin tests so that you get also some overview. So we have at first 3 round-robin tests which are testing the cotton part of the standard. So the cotton cycle, which is done, let's say, at rated capacity with cotton load. We use this standard stain strip, which we used since many years. But we will have a new detergent to be tested, which is called the IECP detergent, which is a substitute for the A-star detergent. These tests will be done in different areas. We have one part which will doing this test in larger Europe. We have one part which will do the tests in China. And we have one part which is doing these tests in Australia. We have different machines which will be tested. Common is that we have the Roscata reference machine, which is tested in most of those labs. And we have horizontal and vertical axis machines. In Europe, we will only have horizontal axis, that's the HA abbreviation, while in China and Australia, we will test horizontal and vertical axis machines. We will test cotton program in 40 and 60 degree or 30 and 60 degree in China. And Australia will also make tests in cold wash. I come to that. Yeah, so these are 3 different round-robin tests. And this means we have 3 local teams which take care of this. And the leader of these regional teams are John Johansson, which is with us today, Jing Song Yu and Zhang Ri, and Phil Robinson. So they are all with us here. And they will be the heads of these regional round-robin tests. And then we have 2 tests on the wool. In the 6456 6th edition, there is new in that on wool also the performance is tested. And we have a gentleness of action test in the wool testing included. So this is all new. So we want also here to test how good it is described and how good is the repeatability and reproducibility. And we have a wool detergent, which was never tested in a round-robin test. So these are all good points why we have to do some round-robin tests on wool. So one is concentrating on the performance and the gentleness of action. And another round-robin test is testing the shrinkage, which is also a new procedure defined in the 6th edition. Here we have a wool team, and John is leading this wool team as well. And we have a new testing procedure for what we call cold water wash. This is for washing machines which do not have a heating device in and which are not using hot water to wash, because this is a relevant part of the market. And I'm happy that we could make this round-robin test for this cold water wash procedure also in 3 parts of the world. So we have one team which is doing it in Japan, we have one for China, and we have one for South America. They are testing also the Vascator reference machine and vertical axis washing machines. They will use this special procedure, which means we have also here a special stain strip, which was new, the cold wash strip. And we have here to test the liquid detergent, which is mainly used in those machines. But we test also the pea detergent. And actually we have 2 liquid detergents, 1 and 2, and we will test both to see how they are comparable. So these are 3 teams which are taken care. The Japanese team is taken care by Kuto Yoshiyuki and Inagaki Kozue. The Chinese team is led by Shang-Ri, and the South American team is led by Luisa Ganzotto and by Esteban Erhard. So actually we have 8 round-robin tests. I'm very happy that we have so much interest and so much support. And here you see the number of participants. All in all, I think these are 55 participants in the individual round-robin tests, but we have 37 laboratories participating to those 8 round-robin tests. 8 or 7, one can discuss about. In Australia, we only have 2 labs, so it's not a real round-robin test. That's why maybe 7 is the correct number. Yeah, and just to show you how global it is, when you look on this map of the world, you see we are not in every region, but we are in many regions of the world which are taking part. And so it's great to have you all willing to take part in this round-robin test. So when looking on Europe, we really span all the area of Europe. And as I said, it's bigger Europe, so Belarus is included as well as Turkey. So it's not only the European community which is taking part. I'm very happy that we have so much interest here in Europe for these 3 round-robin tests, number 1, 6, and number 7. For round-robin tests 2, 8, and 9, we have China and Japan. Also here we have a good distribution of the laboratories. Thank you very much for signing in and taking part in this round-robin tests. Then we have the round-robin test number 10, which is actually called South America, but as you see, we also have one laboratory from the US which takes part and is testing that what is to be tested in this round-robin test. So this is a really good spread all over the world. And here I have a list of those regional leaders together with the name of the round-robin test. So if you have any question, please contact at first your regional leader. He will try to answer. And if he can't answer, he knows whom to contact to get an answer to your question. So let's talk about the execution of this round-robin test. It's testing the CD2, as it is called. This document was published end of December, and it's a committee draft number 2, which is available, and you will get it by your regional leader, regional organizer, as it is said here. And for you as a laboratory, you should take this document and study it carefully to see what are differences to your usual processes. For sure, you will get with this webinar also some hints where differences are, but for sure it will need your intensive study to see really what are differences. And if you are doing that, just look where are things unclear and note it down and send it to us, to me, or to Phil, so that we can take this up and see how we can improve things in the next edition. You will also need some test material for this test, and this material will be distributed to you. I think you got already the contacts from SwissAttest, which is the distributor of the test materials. And so you should have it already, or you will get it shorter. The load, the textile load, which is used in the test, should be available in your laboratory. So you should make the suitable loads for the testing using your garments. The evaluation sheet, which we will ask you to report the data in, this will be made available by your regional leader. And it's your task then to fill in all the data which are requested, which are clearly shown also in this Excel sheet. And you have to fill it and send it to the regional leader, who will check it and then upload it to a data portal where we can then have the evaluation on it. As we promised in our invitation to this round-robin test, we want to keep all the data anonymized. And this is why your lab got a lab code from me. It was distributed via the registration acceptance. And you should use in this evaluation sheet only this lab code and not include any data, any information which would disclose the real name of your laboratory, because we want to keep everything anonymized. And so there are only one person who knows everything, and that's personally me, who knows, and the regional leaders, they have to know it, who knows who is behind this lab code. Yeah, and when we have the results, we have analyzed the results, we will share it with all the labs which are taking part in this part of the round-robin test. So you will get a feedback, and we will also ask you to check your data, and we will give you also some final feedback. So the RRT will be analyzed and feedback will be shared with everybody. So now look on the time plan. We wanted to start on the 1st of January 23 if the comedy draft is available, and it is available. So we can say the round-robin test is started in time. The document, as I said, will be made available to you by the regional leader if you don't have access by yourself. What we are doing is a serial execution in all the round-robin tests, meaning all labs will test the same washing machine. So this means the machine has to go from one lab to the other lab to be tested. And so we will have a series of, let's say, 6 or sometimes even 7 laboratories which have to make the test on the washing machine. So you see, at the end, this is a long process and is time consuming. And therefore, we need to ask you that you keep the time plan, which was set up by the regional leader and which should have been shared to you. So you know when you have time to test it, and you should prepare to keep this time plan as good as possible If possible, you can even anticipate some time so that we can be faster, but don't prolong the timing. Try to keep the time plan because the next laboratory is waiting to make the tests. And therefore, it's really important that you take care of that. Another point which is very important is that you are taking care of a safe transport to the next laboratory. So this means you have to pack the washing machine very, very well. If you get some transport cases, use these cases. If not, make sure that you really have a good packaging and that you make a fast transport to the next laboratory. The best is if you really transport it individually to the next laboratory, because this is much more safe as if you transport it via a normal, let's say, DHL or whatever company is available. So we plan that this round-robin test is ending somewhere in July or September this year. So this means we can make the evaluation and hopefully everything can be finished by the end of this year. Let's hope so. It depends very much on how well you keep the time plan. So coming to the end of my part here, I have to, first of all, give thanks to those companies which are supporting this round-robin test, which is on the first hand, those laboratories which are providing test machines, which are Miele, Electrolux, Haier, Little Swan, and Panasonic. So they are offering these machines for free. You as a laboratory only have to pay for the transport costs from you to the next laboratory. So this, I think, is very generous because you also get a lot of feedback from this round-robin test. You also get detergents for free by WFK and CSC. You get test strips for free by Swisser Tests. All kind of test strips you need. You get the liquid dispenser if needed for the round-robin test and program cards for free from Vascator, so Electrolux Professional, as the company is named. So this means I have to give really big thanks to all those sponsors, which are, let's say, many companies. Let me say some more words on the webinars. So as there are many points new or had been refined, we want to inform you about these changes in the standard compared to the 5th edition mainly by making these webinars. We have identified overall 10 different topics which we want to highlight, which we want to address. And this will be done by experts which have taken part in the development of the standard, so they know the standard very well. We will do it in the next 5 weeks, always Tuesday and Thursday, with a start today. We always start at the same time. I know this time is not suitable for everybody very well, but it is a time which has been, let's say, acceptable for many, but probably not for all. That's why we said we have to record this webinar to make it offline available. This means that you or your staff people can re-watch what is happening in this webinar at any time later. So you will get access to these webinars, and there you can watch it whenever you have time or whenever it's suitable for you to look at it again, or to say to somebody it should look at it and learn something. The webinar is always using the same account as you are using today. So you had been able to use it. So use the same one again for each of the webinars. And the recorded webinar is available on YouTube. It's not available today, probably. It will be available perhaps from tomorrow on, because I will have to reformat the recording, and this may take some time. And then I can upload it to YouTube. And this is the YouTube channel, which you find here on the presentation. This link is also included in the invitation to the webinars you probably have got. And later on, the PDFs of the presentations, as well as the links to the recorded webinar, will be also available at the supporting document website of ISE 59D. And here is the link to this supporting website. So these webinars are about 10 topics, as I said. Today we are some kind of an introduction. Then the next one on Thursday will be about the standard cleaning performance test by Gundula Czyżewski. Next Tuesday on cold water cleaning performance test by Felix Fry and Kuto Yoshiyuki. And then we will continue on the 19th with the new evaluation method for cleaning performance, for some new ways or new procedures on water energy consumption and program duration measurement. We have a new measurement for the temperature inside the wash load by Gundula Czyżewski. Then we continue to introduce to use the gentleness of action measurement by Günther Burtscher, and the wound cleaning performance tests and shrinkage and gentleness of action by Caroline Amberg. Then we come to the new reference programs and the calibration procedure, the new detergents, which we have, and new normalization options and conditioning methods by John Johansson, Caroline Ambeck, Tatjana Friedrich, and Markus Kamp on the 31st of January. Then we continue with the new rinsing performance measurement, the LAS rinsing performance by Michael Munich. And on 7th of February, Markus Kamp will introduce to you the Excel evaluation sheet, which you will have to use in the round-robin test. He will tell you how to use it, what to put in, and what all has to be done. And at the end, we will have some kind of a wrap-up where we introduce to you things which are also new, but not really tested in the round-robin test, or not really included in the round-robin test. This will be the intermittently recurring function procedure, the multi-compartment washing machine testing by René Saube, and the low power modes by Gundula Czyżewski again. So these are the topics of the seminars, and I would be happy to have you and to see you again on those webinars. Yes, as I said, you need to be aware that the webinars are recorded, so you must accept it. And also your comments, I'm not sure if they are also recorded. So when you say something, then perhaps your name shows up and will be recorded. Yeah, if you want to say something, please raise the hand up button. I don't see it by now. And mute your microphone if you don't speak. And yes, at the end, I repeat here that this can be visited later on as well. And this is some option which you should use for your laboratory stuff. And if you have any comments, you can send it also to me at any time, but also now, if you like, we can have a short session that questions can be raised if there are any right now. Because if that's not the case, I would now change over to the second part of this session here, which is the presentation from Phil Robinson. So now we can see if Phil can start. Phil, I mute myself. So then perhaps you can see if
Rainer, can you hear me?
yes, but only with echo.
How is that? Can you hear me?
Try it again.
Can you hear me?
Yeah, that's great, Phil. That sounds great. No echo.
Okay, I'm on the iPhone,
Phil,
but
please
I
say
can't
something.
use the computer. Could I ask you, Rainer, please, if you could step through the latest presentation that I sent through today?
Oh, I shall show your presentation.
If you could do that, please, because I can't put the computer on without getting the echo. So I'm doing it through the iPhone and I don't have the presentation on the iPhone.
Okay, I will manage that. Just give me a minute.
I apologize everyone for this, but the usual gremlins with Zoom, and then when I switched the computer off, it decided to do an update for Microsoft, which took another 10 minutes. It's very frustrating.
Okay, we will manage. Phil. Just. Yeah.
Thanks everyone for joining in. 39 participants is excellent.
Do you see it now,
Okay,
Phil?
yes, thank you very much. So I'll run through this and ask for questions at the end, but if anyone wishes to interrupt and ask something while I'm going through, please do so. We value your input, and my explanation may not be so good. I would appreciate if you can tell me where you need further guidance. So let's go ahead, please. Next slide.
Okay.
I'd like to just run through the background and status of edition 6 and its evolution. It's been a formal process, and it started in 2012 with Ravi. And Ravi set up these guidelines to be consumer relevant with uniform assessment by all stakeholders and to use worldwide to get better cost efficiency and have adequate discrimination and repeatability, reproducibility. So that has been the guiding principle that we've looked at all the way through, and we hope that we have achieved that. I think we have, but you can tell us. So next slide, please.
No, sorry, it was too fast.
Okay, so consumer relevant with respect to textiles. We have cotton, polyester cotton, synthetics blends, and wool. More detergents, we have powder, liquid, and wool. We've expanded the cotton load capability up to and beyond 25 kilos with a formula beyond 25 kilos so that we can cope with just about anything in future. We also have a PES load for wool. We can test with soft and hard water, as with edition 5. We can do a warm and cold water wash. We've got an additional rinsing performance test, in addition to the usual conductivity, alkalinity test. And we measure the temperature within the wash load. Next one, please.
Sorry.
Uniform assessment. we wanted to look for statistical rigor and enhanced discrimination. And this is an extract from the standard itself, looking at washing machine performance, go down through tracer textiles, cleaning performance, and that goes to standard cleaning performance, wool cleaning performance, cold water cleaning performance. We do gentleness of action, we do wool shrinkage, and we do LAS rinsing performance. On the other side, we have water consumption, measure program and cycle duration, the energy consumption, look at low power mode consumptions, the alkalinity rinsing performance, the water extraction performance, and the wash load temperature. Next, please. Usage worldwide. We were looking to try to make the test design as flexible as possible, to have the standard give the basic building blocks so that an appropriate test could be designed in any region that we could think of and for any purpose that we could think of. We've allowed for powder and liquid detergent. As we know, liquid detergent is more and more in use. We've got the loads, cotton, polyester, cotton, synthetic blends, and wool for worldwide usage. Hard and soft water, again for worldwide usage. Warm and cold wash used in many places around the world. Horizontal axis front loaders and top loaders vertical axis with multi-compartment drum machines, and including for the first time intermittently recurring functions, where we thought there may be possibilities where there is a holding tank for the water, for example, for the last rinse, which can be reused, or any other intermittently recurring function. Next, please. Cost efficiency. With a flexible test design, we can produce a test that meets the requirements, but at maximum cost efficiency. The normalization runs are excluded from the test load aging sum, and alternative machines are permitted for the normalizing the load, other than the reference machine. Next, please. Discrimination. The soil removal scores are weighted for balance, and thanks to Rainer for looking at this. This is to make sure that we have balanced scores for the different soil removals, as some soil removals are much easier to remove than others. So these have been balanced and weighted to give an effective soil removal score. We have the new LAS rinsing performance test, which is showing much better discrimination than the alkalinity test. And we have the international round robin test about to commence for practicality, repeatability, and reproducibility confirmation. Next, please. So, global acceptance. We wanted to look at varied international practice with one test machine and multiple runs, and we called this a unit class because it looks at an individual machine and how it varies over different runs, or a multiple test machine and one run family class, or a combination of both. And then the statistical analysis requires independence of samples, so that initial conditions must be identical for each sample, and we take a minimum 3 samples for significance. Next, please. Let's look at the unit class. This is the variability of a single machine with a single program over multiple test runs, and we've assigned a minimum of 3. This is the traditional IEC test with, let's say, 5 runs with no normalization in between. That's fine. It tests the variability of a single machine, and we trust to the manufacturer that his quality control is good, and this would be representative of production. Family class is production variability with multiple machines, with a single program over single or multiple test runs. And this looks at perhaps, I won't say better, but it's another way of looking at the production variability rather than extending it by a single machine's performance. But the separation of the test method results from the number of runs in a test series, and we make sure the independence of each test run or test series. So the test load is normalized between each test series in the unit class and or test runs in a family class. We either have a test series without normalization between the runs of a particular number of runs, and then a repeat test series must go back to the same initial conditions as that test. For the family class, there is normalization between each test run so that all test series are independent in any case. The key finding from this is only like for like results may be compared. There must be identical test class, identical test machines, identical test program, and an identical number of test runs for the results to be compared. Otherwise, it is invalid. Next, please. Global flexibility and statistical rigor of the test design. This comes out of the standard itself. And as you can see, this is how you choose which test class you would like to look at. Manufacturing process, variability on the right-hand side, and performance variability on the left-hand side. Next, please. Flexibility, because it allows variability of unit performance and or family production process. We can look at single, multiple, or multiple machines over single or multiple test runs. We can look at horizontal and vertical axis, multi-compartment machines. As I said, we can look at warm and cold water wash. We have different textile loads, cotton, polyester, polyester cotton, synthetic blends, and wool. We've got the different detergents, powder, liquid, and wool detergents. We've got a gentleness of action, wash severity evaluation. The rinsing performance test can be alkalinity or LAS, and we've got the temperature and the wash load. All of these items allow immense flexibility in designing a test series. Next, please. The new detergent. IECP, the powder detergent, replaces the Edition 5 IECA star. We initially were going to reuse IECA star, but there are health and safety concerns over sodium perborate. It has been banned from May this year in the EU, and sodium carbonate replaces that. We have taken the decision that IECP will move forward into Edition 6 and also replace IECA star in Edition 5. We have a new standard liquid detergent, IECL. This correlates better with market offerings, and we have two types. IECL1 was developed in Europe, IECL2 developed in Asia, and both fulfill the requirements of an international reference detergent. We have the new wool standard detergent, ICW, for washing performance and shrinkage in line with consumer relevance. And we have new associated dosage instructions for those new detergents. Next, please. We have new measurement and evaluation methods. We've got the wool cleaning performance. As I mentioned, LAS rinsing performance with, please note, the alkalinity method is retained. Gentleness of action, low power mode consumption, temperature inside the wash load, intermittently recurring functions, cold water washing machines. We've replaced washing performance by cleaning performance, which is the soil removal. And with the balanced weighting of different soil removal scores, we have a more balanced cleaning performance evaluation. Next, please. We have changed alignment of the standard test strips. When attached to the base load item, the charge number is now towards the towel. Next, please. We have alternative conditioning methods. The laboratory ambient, climate chamber, or bone dry, we can have it at 23C or 65% humidity. We can have it at 20C, 55% humidity, or bone dry in a special tumble dryer. Next, please. We have different methods for preparing the test load, and these are the flow charts taken directly from the standard. I commend them to your attention. The base load items, according to specification 5.3, are they new? If yes, pre-treatment. If no, are they normalized? Yes, items conditioned. Yes, go to load composition. If no on those points, go to normalization, same water hardness. And the next point 2, items conditioned. No, go to 6.4.5 to condition those items. Next, please. Oh, sorry, I'll go on to load composition and age. And from the load preparation, this is how to mix the load to get the load composition and age consistent. And again, we've got the flow chart here of how to do it. It's quite easy to understand given this, and then to go through the various age and mixing measurements within the standard. Next, please. Load treatment prior to testing. Preconditioning for the new unused test load. This minimizes any production residuals and determines the initial condition. Normalization of the test load minimizes previous test residuals. We did a number of tests, and I thank Gundula for this. We have significant detergent carryover noticed in particularly the previous 5-run test series. As there was no normalization between the runs, detergent built up significantly from the first run to the 5th run. By normalization, we try to eliminate that carryover either between the test runs, or if it's a test series with unnormalized test runs, must be done between the test series. Conditioning the test load equalizes the residual moisture content and determines the conditioned textile mass. We don't count the normalization cycles in the age calculation now, and new is the range of average load ages extended. The weighted average now 20 to 60 runs. Next, please. These tables are taken from the standard. I won't go through them in detail. They're here for later reference. The loading description has been extended up to and beyond 25 kilos for cotton test load. Next, please. Same thing for the mixed poly cotton load. Next, please. Synthetics blend, same thing. And next, please. PES for wool. And we have that here. As I said, I've copied these into the presentation for your reference to make it easy. Next, please. Multi-compartment machines. We've got new definitions, measurement and calculation methods for the multi-compartment washing machines, either in simultaneous operation or sequential operation, and a single compartment operation is treated exactly the same as a single compartment machine. We have allowed in sequential operation for reusing last rinse water as initial incoming water in the second drum. Again, enormous flexibility in how to design a test series. Next slide, please. Supporting documents. We've relocated the supplementary information to the free access supporting document dashboard. And I've put the link in here under supporting documents where you can find the reference machine maintenance information, test material supplier information, expanded uncertainty values, and any other pertinent information for the general public. Rainer, I'm not sure, will we be putting here round robin summarized results on the supporting documents?
maybe, no, yes, we have it on there. We have the final conclusions we have there in terms of expanded uncertainty values for all the measures.
Okay, thank you. Next slide, please. So the formal process, how was it developed? MT15 is tasked with with Edition 6 creation. This is the maintenance team. It has very broad-based international membership, and we meet biannually, and we set up sub-teams for the specific tasks to write Edition 6, to test the laundry lab load and loading method, to test the standard materials, to set up the round robin test, and if there's any other, we'll set up another sub-team to look at that. Next, please. If you've identified any other task that MT15 should be looking at, please let us know. And all SC59 subgroups are available for assistance. Please let us know. Next slide, please. And the process was, CD1 was released January 22 without the result tables. We were still working on them. The comments were finished reviewing by May 22. The comments were incorporated, reviewed by October 22, and Annex S was completed November 22. CD2 has been released for your consideration. The round robin test will now commence January to June 23, and based on results from this, we'll prepare the CDV and the FDIS, and we're expecting Edition 6 to publish without expecting any sort of major problem by first quarter 24. Next one, please. The differences from Edition 25. We went for the global flexibility and statistical rigor. So identical initial conditions of samples by normalization with interseries or interrun, depending on the test class. This is a major difference. For a single machine, we retain continuity with editions 3, 4, and 5. A unit class over multiple runs evaluates the single machine and program variability, 1 program and 5 runs in the test series, and normalization between the test series. Identical initial conditions. Next, please. For multiple machines, we extended the applicability, and I won't run through that again, but as it's used in Australia and New Zealand, there 3 units on a single program and a single run in a test series are intended to represent the population sample. And normalization between runs ensures identical initial conditions. But there's also a combination possible. You can have single, multiple test machines. You can have single, multiple test runs, and there can be interseries or interrun normalization. Again, to give the greatest flexibility for worldwide application. Next, please. Rigor. We have to ensure that each test run or test series, depending on the test class, is independent for statistical analysis. So we've got to have initial conditions for each test run and test series. Identical initial conditions by preconditioning, normalization, and conditioning the test load. And the minimum number of test runs for statistical significance should be set at 3. Next, please. This is just a basic statistics refresher to help you. I needed this, and I'm sure many of us have forgotten much statistics. When the mean and standard deviation of the entire population is unknown, we try to estimate the performance by sampling. Single test run on single unit gives you no information on the population. Test series of test runs on a test machine gives a sample mean and standard deviation that could reflect the entire population, but we don't know. So we assume a normal distribution and students' t-hypothesis method and the independence of the test series runs. Absolutely vital, identical initial conditions. Next, please. I've put a hyperlink there if you wish to refresh the statistical rigor. The calculation relates the test sample in units mean, x bar, to the entire population mean mu. So we've got an x bar of the sample related to the population mu using students' t-test method. And where the true population standard deviation sigma is approximated by S, for sample sizes n less than 30, we have this equation. This mu can be found with a confidence level 1 minus alpha by knowing the measured average, x bar, and standard deviation x. Next, please. We can relate the number of runs n to the confidence level with the degrees of freedom and t critical values for selected confidence levels. The critical values t depend on the number of runs and the expected confidence interval. Next, please. We're looking at 95%, and in plain language, this is what we get. X bar misses you by less than t s over root n with 1 minus alpha certainty. So for example, the margin of error with 95% confidence level with a significance level alpha equal to 5% approximately doubles for 3 test runs compared with 5 test runs. This is a good way of looking at how effective the number of test runs is. Next, please. And just looking at the representation of the error bar size as a function of sample size, this shows that the sample population may not even capture the mean, the true mean of the population. And the error bars here show what sort of distribution we get with various error bars. So I commend this to you. Please have a look, and it will remind you of the statistical significance of what we're trying to achieve. Next, please. Again, I remind everyone that the results may only be compared for tests under identical conditions. So the unit class, the same test design, machine type numbers and number of test runs. The family class, same test design, machine type numbers and number of test runs. But unit class and family class results are not comparable. They cannot be compared. Next, please. Changes from edition 4, edition 5 from edition 4, the load, modified test load requirement, loading and folding the test load items was better suited, reference washing machine, the new Wascator CLS was given, a new reference program, new informative annex, and other changes were an expanded stain soil test, soft water option, shrinkage specimens revised, refined rinsing efficiency method, that was the alkaline method, low power modes off and left on were put in, and an annex was put in on uncertainty of measurements. Next, please. Edition 4 from edition 3, reproducibility and repeatability of the test results was improved, the tolerance limits were increased, and the instrumentation measuring optical reflectance was better refined. The load reflected market offerings, cotton base load, easy care textile base load, polyester load. Tolerances were changed, pre-treatment, normalization and conditioning method was more defined. The reference washing machine water quantity was adjusted and controlled more precisely. And other changes were IEC A-star was introduced, correction formula for hot and cold water was modified, and shrinkage specimens were slightly revised. Next, please. That's the end of my little segment. So thank you. And if you have any questions now, please go ahead, or we can wait until the end of the session. Are there any questions? Thank you very much, Rainer.
Yeah, thank you for a lot. So give me a minute to start the next one. Where is it? So are there any questions? I think it was a lot of information, and for sure, Phil has just given an overview. We will go much deeper into detail in the other webinars, where we will talk about the specific points in more detail and show you with more data, with more information, what is behind all of these changes, which Phil has just stressed. So I see no comments, no one asking something. Then let me continue with two other points which are new in the 6th edition. And these are the test instrumentation and the laboratory internal guide and protocol. So test instrument accuracy is my first point. It is about how you specify the laboratory instrumentation. And there are different ways how to do it. And yes, this is new what we are doing, but it is following that what is agreed in international electrotechnical standardization and measurement. And this is defined in this IEC ISO standard 17025, which is a measurement standard which defines in general all about measurement methods and measurement accuracy. And in the standard, it is defined, and I cited it here, that equipment and its software used for testing, calibration, and sampling shall be capable of achieving the accuracy required. So this is the main sentence. And it clearly says we have to think about what is the accuracy of the testing itself, and to define how this accuracy is required for each individual testing. And this is what we followed as a guiding principle for the 6th edition, that for each measurement, we shall define what is the measurement accuracy required. And this measurement accuracy we define in the term of the measurement uncertainty or the expanded uncertainty, which is a special way how to express the uncertainty of a measurement. This is the same what Phil has just shown to you in this normal distribution. So this little curve which he showed, where you saw that the outest part, this 2.5% on each end of the distribution, this is, let's say, outside of this distribution. This is the 95%, what is inside, which is covered by that. And this is the range of the expanded uncertainty. And when you have a normal distribution, this expanded uncertainty is just twice the standard deviation. So this is called a coverage factor of 2. So twice the standard deviation, which gives you a 95% range which you are covering. And this is called the expanded uncertainty. And this is the way how we decided to define the required accuracy of a measurement. And this is defined in the standard. It's defined on one side in the text of the standard, or it's defined in the Annex S, which is the reporting tables defining. And there you find what is requested as some accuracy of this measurement. The consequence out of that is that you as a laboratory have to think about how you can provide this expanded uncertainty. Because the measurement is not just only one instrument which you are using to read something from this instrument, which is take as the measured value. Normally, an instrument or a measurement needs more instruments. The measurement is forming something like a measurement chain. So you have a sensor, you have some transducer, you may have some device which is changing the measured value into some physical value, and then you have the display of the measurement instrument. And so these are all linked together, and they are defining the accuracy, the overall accuracy. And therefore you have to look on the whole measurement chain and think about what are the accuracies of the individual parts of this chain. And this will form then the overall expanded uncertainty of a measurement. And what we are defining in this NXY, C is a minimum resolution. This is how you read the measurement instrument, how much, let's say, digit after the comma are provided, and the minimum accuracy, which is this expanded uncertainty at a minimum what you need. For sure, you can be better, but what is defined in this Annex Y is a minimum of the accuracy which is needed. And this means, as I said, you have to check the whole measurement chain to be able to see what is the overall accuracy of your measurement. So here I say again, so it's a sensor, it's a calibration of the sensor which introduces some accuracy. It's a transmission, it's a conversion of the data, let's say from analog to digital. It's the instrumentation itself, and then this will give you the measurement chain. So looking on this NXY, I just have put in here two examples. The one is for program energy. So it's normally measured in kilowatt hours and given kilowatt hours, but the accuracy needs to be at 1% at minimum, so plus minus 1%, or when we use it for low power modes, for example, then it should be better than 8 watt-hours per day. So if it's a long-lasting measurement as for low power modes, then you should look at that. And this is because you have to apply it also in the sense as it is used. You have not only to look at the let's say optimum value which is given as an accuracy, but you have to see under which conditions we are measuring. And so we have to look on the, for example, distortions of the waveform, and to see what is the accuracy if a certain distortion of the waveform is assumed. And you have to consider those points as well when looking on the accuracy of your instrument. The second example is about the mass measurement. Here we have different requirements for the accuracy for the different measures which we are doing. So for this kind of mass measurement, we have different ways or different topics where we are using it. It's a load mass, for example, which we are measuring. We are measuring individual load items. We are measuring the detergent mass. We are measuring the titration mass. And for the LIS measurement, we need the detergent mass with a much higher accuracy, because here we are working with much lower quantities of the detergent. And therefore, you can't use one balance for everything. You need to have different balances for the individual things what you are measuring. Yeah, so this is the new way how we are defining it and how we are looking at it. And you as a laboratory manager, if you are a laboratory manager, you have to check that and you have to think how you can fulfill this. And an additional point was coming up, and we defined it also in this Annex Y, because also we have measurements which are continuously recorded, like, for example, the ambient temperature, the ambient humidity, or the supply voltage, or the supply water temperature. So these are values which have to be continuously recorded. And there we are also defining a target value where you should be, like 23 degrees for the ambient temperature. But for sure, this is not just a value which you read off once during the test, and then it is, but it should be throughout the measurement maintained, this ambient temperature, because this ambient temperature can have a lot of influence, for example, on the energy measurement. And therefore, during the whole process of testing, the ambient or all these continuously recorded values should be within a specified range. So we specified a range, for example, ±2 Kelvin for the ambient temperature. But there should be some way how to verify that. And okay, one can think and say that we want to have 100% of all the measured values within this range. But then you are never sure if there are some outliers in, if this should already make your test invalid. And therefore we said, okay, we would be sufficient, we would be satisfied if 99% of those values are within this specified range. And it's on you then to verify this. And we ask you in the test report to include the average value of those measurement values, those continuous measurement values, and to record that and value, and to record the percentage of values which are outside this specified range, to make sure that we have this 99% of the values inside. Sorry. So this is a new way how we are looking on this continuously recorded values in this new standard. Another point which is new is it's at least partly new. It's the Annex K, which is called Laboratory Internal Testing Guide and Protocol. Because we have a very complex testing procedure. It's not complex with the 6th edition. It was already complex before, but it is complex in itself because we are testing 2 washing machines at the same time. At minimum, we have the reference machine and the test machine, and we are testing many different parameters within one test cycle. And therefore, it is really complex, and you need to be well acquainted with the test procedure, and everything needs to be well set up to be able to make these tests in parallel within the short time interval. And therefore, it is a good laboratory practice that you must organize your laboratory and also process very well so that you can manage this process, this testing process, well within the short time interval. And this means you have to have a operating laboratory very well. So everything must be already set up before you start a test in your laboratory. But also the test machines must be well set up and tested and checked that they are ready to run before you start a test series. And also your measurement processes must be also well organized, and also the data logging of all the data which are measured, which are to be measured. This must be well prepared. And as these are, let's say, a lot of things which need to be done, it is necessary to have this done for getting accurate and reliable results. Because you also have to think of that you must try to avoid any mistake, because then you would leave a lot of, let's say, efforts as not usable. And therefore, this is very important to have this kind of process well established, so that you really get at the end valid test runs, and also test runs which are traceable, which means that later on you can look back on your recorded data and you can prove that all was set up as it should have been, so that the tests are really treated as a correct test at the end. So for this, it has been good practice to set up something like an internal laboratory testing protocol, which defines how the testing of a washing machine in this case should run, not in saying use the standard and do it like the standard, but saying in detail how this is done in your laboratory. And this is what is asked for in this Annex K. This Annex K gives you already a structure how this internal testing protocol shall look like. So it defines also in the different sections the different points, what I said, that you have to look on your infrastructure structure, which is laboratory specific. So only you can say what kind of switches needs to be on and what kind of pre-tests needs to be done to ensure that the laboratory is done. And you also have to do that for all the testing equipment which is needed, and also for the test machine needs to be done. So also you need to have some kind of a checklist for each washing machine, what needs to be done in your laboratory to ensure that the test machine is okay, that it is properly connected, pre-tests are done, dispenser is cleaned and dried, and so on. So there are a lot of things which need to be done, and I think it's a good way to make it in form of a checklist. And also during the test and after the test, you have to make sure that all what needs to be recorded is recorded during the tests. And also here some kind of a checklist is helpful, or some kind of a reporting sheet is helpful, that you are really guided through the whole test, and all what is needed is really recorded. And also after the test, you need to have some kind of a checklist, what is needed to be checked to ensure that the program, the run was correct, and everything is done as it should have been done. So this is done and given in more details with examples of how such an internal laboratory test protocol is set up and is given. And you should look at that. It's in Annex K3, where a lot of points are mentioned, which you should look for in preparing such kind of an internal testing protocol. And that's what I want to give you at hands, so that you think about, and perhaps you still have time to do it, or to update it if you have it already, update it according to that what is requested for the 6th edition tests. So this is what I wanted to share with you today. I come to the end. I want to thank you very much for your attention. I think also in the name of Phil Robinson. It was our first try, so maybe not everything was perfect, but I thank you very much. We now have time for questions. I again want to highlight that you can watch this later on YouTube, and you can get in some time the presentation on Supporting Documents website later on. But at the end, again, if you have specific questions to the round-robin test where you are taking part, please contact at first your regional leader of the round-robin test. They are your contact persons. Comments are anyhow welcome to me. And yeah, this is, let's say, close to the end of the first webinar. Again, we can now have a question and answer session. If there is anything what we can clarify now, you are now able to, I think, switch on or to ask something in the chat, switch on your microphone or ask something in the chat or raise your hand. We are happy to answer your question now, please. I don't see anybody raising its hand or asking questions. So I thank you once again. I invite you to the next webinar. It will be on Thursday, so 2 days from now, same time, same link. It's about the standard cleaning performance test, and it will be Gundula Czyżewski giving you this webinar. So thank you very much. Have a good day, have a good night. And see you in 2 days from now.
And thank you from Phil too. Just before the end, I have woken up my computer and it is working now. So thanks for your patience.
So thanks to Phil and Rainer.
Yeah, thank you. Welcome.
All have a good day.
Yes, bye.
Thank you very much.